Hello, how are you guys doing? In this video, I'm back again with a project that I want to describe to you. It is a very common project in data engineering, and let's describe it. So it's an end-to-end project that will, it's a real-world scenario that I've worked on many times, and this project will help you get real-world experience and get you a job and practice your skills in data engineering. So let's start. What's the context? So imagine you are working in a health system, right? Where they want to process data, they want to build a data warehouse or data platform, and they want to process data from their source relational database, let's say Oracle, and this is just one database source that they want to ingest the data from into a data lake. However, you are not permitted to access those Oracle tables directly, like for example using a tool like ETL2. You're not allowed to access them because they are critical for the application team. So you are now expected to ingest the data using change data capture tool, for example, Click. So this part is set up for you, where in the organization setup, this Click Replicate is a CDC tool that will read the transaction logs of the Oracle tables and write the data into the landing zone of your data lake. Now, once the data is written there, the CDC tool can do the full load and the incremental load. So it's basically all the changes, incremental changes are getting written instead of the deletes into the data lake. The business request here is to create a pipeline using Databricks and Data Factory that will process the data from the landing zone and write to a delta table in your bronze zone in your data lake. Your pipeline should run every hour and be able to process all the new files that it sees in the landing zone. After processing a file in the landing zone, it should move it to the archive folder. That way it frees up the incoming folder. Your pipeline should handle when the incoming folder is empty, it should do nothing, because sometimes maybe there's no change in the table, in the source table, so the incoming folder will be empty. So the pipeline should not do anything. And your pipeline should be parameterized so that for every given table, the same pipeline can run for multiple tables using a configuration file in your data lake. This configuration will also have the table names and the primary key columns of each of the tables that you're trying to process. Now let's look at the architecture. So the architecture here is like this. So this is the architecture. So you can see you have your source, Oracle source, you have the Click Replicate, is pushing data into your landing zone as JSON files, right? And then using Databricks Data Factory, be able to take those into your bronze zone. Now we're not gonna do anything with the silver and gold zone. We are not doing any joins or aggregations. We're just focusing on this part from here to here as our end-to-end data pipeline. So now that you understand the business requirement, let's look at the breakdown. So the breakdown, you have to understand what are the tools that you will need for this job. So you basically need a Azure Data Lake, which is where you're storing the data, your data factory, and your Databricks. These are the components that you need for this project. That without without mentioning the obviously an Azure portal account. The goal is to build this ETL pipeline that can process both the full and incremental load for the data lake tables into your Delta Lake in the bronze. So this is the goal, is to do full and incremental, and to do it for multiple tables, just one pipeline. So these are some prerequisites. You should know SQL and Python. You should be able to set up your infrastructure, like make sure that you provision these services. You have created a couple of containers, like your landing zone, refine zone, governance zone. So landing is where we'll be pushing the JSON files. Refine or bronze zone is where we would put the Delta tables. Governance zone is where we have a configuration file. In the landing zone, we have two directories, the input and archive. And then we will also step 5. And by the way, all these steps, as a data engineer, you are supposed to kind of figure it out based on the requirement. Making these steps so that it's easy for a beginner to learn the approach, but in the real world, if you're a senior engineer, you might be required to figure out what you need to do to deliver this work. So you have created these folders where you can upload these files. Inside the input directory, you have 3 subdirectories where you write the for each table you have the different directories, and I'll show you everything as I'm doing it. And now, before we get into the logic, let's look at some of the first steps. So what my first step now is to try to create a Databricks Notebook that basically reads. If I'm doing this, I'll first design the notebook to be able to read the data without any parameterization. Like, how can I process one table from the JSON file all the way to a Delta table? Now let's show you the setup. So here's my landing zone. Forget some of these other folders. So I have my input folder. This is the address table. This is the full load file, and you can see I create some fake records which I'll upload in GitHub. They are all in JSON format. So I create this full load. There's an incremental file and incremental file. So Your pipeline should be able to, if it sees full load, incremental, if you're able to process everything, if it sees only incremental load, should be able to also process it. One thing you need to understand in this requirement is part of the data analysis. If you understand that in the incremental load, it has an additional metadata column called action type, telling you if it's an insert, update, or delete. So that's one additional column that you notice in the incremental file. It doesn't exist in the full load file. So let's go to the notebook. So this is the notebook, how to process data from the input to the refine. And here I have created my external locations. It's Unity catalog enabled. And in the next video, I will show you step by step how we process this, because I have to start the cluster, which will take some time. So catch you. Hello again. I am back to this project here, as we were describing last time. This is the second part. Just to recap, we have a project where we are reading data from a source database using a change data capture tool into our data lake, and we're trying to process this data into a Delta table. There's a question that most people ask is, why are we not pulling directly from the source? There are many reasons. When you pull directly from the source, sometimes it's hard to figure out how to get the deleted records. So also you put a lot of load in your source system if you connect your ETL2 directly to the source and create the source tables. So these are some of the issues that people like to avoid. But with the change data capture tool, you don't read directly the source table, you read the transaction logs. So it's a much better. You can capture the lead. You don't have a lot of load on the source system. It's very, very efficient. It can give you near real time data. It's like you're pushing the data to your data lake instead of pulling it. Now, let's go over the first part of our pipeline. The first part of our pipeline, now we have our data landing into our data lake in the landing zone. Those JSON files are just landing there. I showed you last time. But now we have to figure out, how do we want to design our notebook, our Databricks notebook, that will read those JSON files, understand the various intricacies that needed to be done. So one of the things is, because we are trying to build this framework, we need to figure out how to parameterize the notebook. But before we do that, let's first do the easy, happy part first. How do we write a notebook that is hard-coded for one table? So first step, I'll read the files, write it in the code to read the files from the directory into a data frame. Ensure your code can handle the full load without incremental, as well as the having incremental value. So this is where doing some analysis to understand the data structure of your incoming files. The incremental file, like I said, will have an action type field. But fourthly, you have to dedupe, because sometimes there's a chance that when you're reading the incremental files in one batch, let's say you're running your pipeline every 1 hour or every 30 minutes, the same primary key record can get updated multiple times. And you have to figure out a logic to get the latest version of the record for that in that batch, for that primary key. Another thing is you have to also figure out how to write the logic to insert into the data file the first time. If the file already exists, your target data file already exists, then you want to do an offset, right? You have to want to do an offset. You don't want to completely overwrite the file because remember how it works is the first time the CDC2 reads the source table, it will do a snapshot, which is like a full load of the table. But the subsequent times, it's just gonna just write incremental files. Like if it's just one record that you see changed, you're just gonna write that one record into a file, into a JSON file. And when your pipeline runs, it's gonna only process just that one file. So you always wanna do an offset. That way your logic is idempotent, right? You are not overwriting everything. You just keep updating it if it already exists. If it's a new record, you insert. So this is if there's no finally if there's no incremental files, do nothing. You don't want your pipeline to fail. You don't want it to read an empty data frame. If there's no incoming file for that batch, okay, skip that run. So let's look at the code to accomplish all this. I believe my cluster is up now, and this is the primary key. So let's look at the code. So these are different things that, as a data engineer, you may not think about know these things up front, like because if your first time working on it, you might end up figuring out as you go. But since I have experience, I already know all the steps. But it's a good process to kind of have a pseudocode if you can. Think about the different scenarios that you can have when you're doing your pipeline. Try to break them down and make sure you can keep every point when you're developing your pipeline. But sometimes you won't know everything, but when you work on it, it will be obvious and you can uh, code it. So let's look at the cost size up. So let's look at this notebook. So again, I explained the difference with the incremental file and the full load file. So first step, we import our libraries. These are refined zone path and landing path. Now, behind the scenes, I have set up my Unity catalog, meta store, giving access. I'm not going over that in this video. I think that's another topic you can, there are many tutorials on how to do that. So this, I've set up my folder paths, external locations. Now this is how I read my JSON file. Notice multi-line through. So I read my file, I can run it, and in this case, it will read. I'm hard coding it at this time for the address table because, like I said, this is the first part. I'm creating it hard coded method. So I run that, it works. So it's running, as you can see. It's able to do a merge schema. That's one thing with Spark. Even though I have a full load and incremental files, this action type column, for when it's full load, it appears as null, but for the incremental records, it has the value. So it's able to merge the schema between the full and incremental files. So I don't have to do anything there. But one thing I have to do though is make sure that I don't want to have these nulls. I want to say that if action type field exists, right? Like default the values to uh, from null to insert, right? If if there's a action type field existing in this data frame, I want to make it an insert because that's mimicking the full load. But if the action type field doesn't exist, let's say I'm only processing incremental, sorry, I'm only processing the data that was just the full load. There was no incremental uh, file. There was no incremental load. Then I want to add a column called action type. And this nuance is very important. And the only way to test this out is when you actually test your code by, if you remove these incremental files, right? If you just do the practice at home, I will post all the artifacts for this project in my GitHub. But if you remove these incremental files and leave only this full load file, and you end up running the logic, you will notice that the action type field is not there in the full load. So, but when you eventually write to the delta table target, it's not good that you don't have this field, because then the next time you run it in the incremental record, they will have this action type, and at that time you already inserted to your target, and you have to alter table or deal with it then. But so it's better off I just handle it initially by checking that if the action type field does not exist in the incoming data frame, make sure I add it. That way my schema is consistent. So as you can see, I already have insert and update and delete. So this is good. So I have this that is done. So the next step is to do what? This part is where I am doing the window function, because in this batch, as you can see, sometimes the address ID is the primary key. Address ID 11, there's a chance that there are multiple versions of them in the same batch. But I don't want to insert all this. It duplicates in my view. I don't want to insert the 3 version of this address ID 11. I just want to keep the latest version of the record based on the last modified date. And this last modified date field is always existing in all the tables, same as the action type, right? These are always going to be there in all the tables. So it makes it easy for me to use this column to figure out this logic. So as you can see, I pass the primary key, I do my window function, shown by this thing, address ID, order by modified date, do my row number, and keep the row number equal to 1. So as you can see, when I run this, I get the values, and keep only the ones that are more recent. So this is what I have. Now the next step is what? To definitely check that the input files exist. Wait, this step was just debugging. I don't think you need that. I'm just creating a function for now, file exists function, but we'll get to that step again. But for now, this part is where I am reading the config file just for reading sake. But okay, here's where it's important. So here in this place, what am I trying to do here? I'm trying to check, does the delta file exist, right? If this delta file already exists, the target, I want to what? Do a merge. But if it doesn't exist, I want to do a full override. So that's why I create that function. And just to be safe, let me run these cells so I don't get an error. Yeah. So I'm running it. As you can see, it's real code, it works. So this part is where it's actually doing the work. So at this point, Delta file already exists because I've run this multiple times. So what it's gonna do is gonna do a merge using, and this has to do a merge in PySpark. You say when match update, when not match insert. So it's very easy. We are not specifying the column names and all that. We're just using these functions, and it's gonna update all the columns, inside all the columns for us. Only thing we need to specify is the primary key. So in this, if you look at this code and you're able to do this for one table, you should be, as a data engineer, you should be thinking, okay, how can I make this way more dynamic? Because do you really want to write this notebook for if you have hundreds tables or 20 tables and you want to do the same process them into your data lake? Do you really want to write 20 notebooks and all you're going to be changing is the table name and the primary key? No, you don't want to do that. You want to make this dynamic. And that's what we're going to look at in the next notebook, the parameterized version. This is after you've done the one that you've done with the hard-coded version, the parameterized version will basically show you this process. Okay. What's going on? All right. So the parameterized version is this. All I'm doing now, taking the original notebook, I am passing in this table name as a parameter because I want to actually input this from my data factory. That will come later. You get the table name as a parameter, widget, and then in my folder path, you can see I make it dynamic to pass in the table name because, as you can see, I have multiple tables. I just need to parameterize it, and then here's the key part. If the file doesn't exist, boom, I stop exit the notebook. I stop processing. That way, I don't encounter any error. My pipeline just finishes on time. No need to keep going. If there's no any files to process, just end the process, the notebook. So now, if there's files to process, fine. We can read those files again. But in this case, I read the primary key. This place I'm getting the primary key for my table. So I'm getting the primary key for my table. Let me change this again to address. Sorry. So address, and the primary key here is, sorry about that, I didn't run this. Yeah, now, so this is, I have this file that stores the primary keys of the table. So it's a JSON file that I stored in my landing zone, in our governance zone, sorry. It's a JSON file that has the table name and the primary keys. You see the structure. So because for some tables that have multiple primary keys, I store on an array. That's the good thing about the JSON structure. So I read those into a data frame, and then I filter for the table, and I derive the primary key, right? As you can see here. Now, once I have this primary key, all I have to do is to, continue with the processing that I normally do, read the input files, do the same thing I already did with the action type, and then here's where it helps now. So now I have the primary key stored in a variable. As you can see at the earlier step, I had it stored, collected, and stored in a variable. And now I pass that variable to my window function, primary key. This will work if there's multiple primary keys, there's just one primary key. It's I'm passing like a list. It takes a list and it's gonna be able to figure it out. So this will work. So I already get the last version of the records. Again, this is my function to check if the file exists. And here, the merge condition, I can delete this actually. I was using it to test out my stuff. So this merge, as you can see here, oh sorry, shouldn't have done that. Yeah, this merge condition actually, this is where I create the merge condition statement that I will use to pass to my merge statement here in PySpark. So what I'm doing is basically, if there's multiple columns in the primary key, just like I showed you here, source dot address ID equal to target dot address ID. So it will do, I'm writing a formula to create that string. If it's multiple, it's gonna say for the number of columns, source dot column name equal to target dot column name, and source dot column name equal to target dot column name. As many columns that from the primary key. So this is what I'll do for that. As you can see, this is generated. But if it was multiple, if it's a table that has multiple primary key, you see it will add the and all that. So now I use that to run this again. This pretty much, if the file doesn't exist, it's gonna create it's gonna write the file. But if it already exists, it's not gonna, it's gonna do the merge. So there you have it. It's running that, and here is I confirm that the load was successful, as you can see here. And then finally, I do the archiving. I archive the files that have after successful load. I archive the files into the archive folder. All the files that were in the input, I put in the archive. Now finally, this is the way to do it. Once I've done this in a parameterized way, now I can create the end-to-end pipeline by using Data Factory. I'll do a lookup activity where I pass in, as you can see, all the tables that I want to process. It could be hundreds of tables here. I pass it to for each container, for each iterator. I put the notebook, the parameterized notebook, into this for each container. And all I'm passing is the item.table name, the table name that's coming from the lookup activity. And when I run this, it's going to iterate over the whole, all those tables and process all those files. So there you have it. This is end-to-end, simple pipeline. Obviously, you can do more complicated stuff, but this is the gist of the work. And I'm gonna post all these artifacts for you in the GitHub for you to go and replicate it. Thank you so much.